When we're talking about system automation, we're talking. I'm really speaking on uh, a couple of pieces here, and those couple of pieces are Git. So you can have a GitHub, which we do, and most of the time you'll find in the industry people ask you, "What do you have?" Especially if you are a programmer or anything of that nature. They're like, "Do you have a GitHub account?" And usually they're looking for you to have a GitHub account so that they can see whether or not you what your coding style is. So basically, your GitHub account is like your resume. Like you say, hey, you code, but then in order for you to really show that you code, they actually want to see your GitHub account so they can go look at your work. Another reason why people like using GitHub as I guess, as a quote unquote resume is to see what open source projects you contributed to. So some of the open source projects that are huge out there is OneOps, which comes from Walmart Labs. So this is Walmart's contribution to actually open source. So they actually have a Slack group as well too. So like if you ever want to hop on, if you want to build yourself up on a as a for a resume builder, is hop on one of these open source projects. Now, hopping on an open source project doesn't mean you necessarily have to code. You can start looking at documentation. You can walk through and say, "Hey, this information isn't spelled correctly," or something of that nature. So there's different ways to give to the community in terms of building your resume and contributing to an open source project. I wanted to contribute to OneOps because I look at people like I look at Netflix and I look at Walmart and even Bank of America and Chase is actually they're coming out with an open source project. But those are big conglomerates, and then you have to think about how big they are in terms of. Can anybody hear me? Because somebody said they couldn't hear me. Can you hear me? Oh, okay. All right. I sure. All right. So Sergio says he can hear. Shanika says she can hear. Shantae, I'm sorry. You should be able to hear. But these big companies have open source projects. They also have, there's other projects out there like, let me see, there is, I think, I forget what Netflix open source project is. Hold on, let's see. Doo doo. That's big data. I forget the name of it. It's actually on a podcast we're getting ready to release about what their name of their project is. But here's their GitHub. I'll send this to you guys or to you, ladies and gentlemen. Sorry, hold on. Let me go back and see if I can find what it actually is called. Let's see. I don't think it's Chaos Monkey. Yeah, it is. It's Chaos Monkey. That's one of the bigger ones that you'll find. And you guys can take the time and look these up. All right, that's that. Here we go. Well, here we go. It was released in 2012. So here's a little more information about it. And um, then there is, see, Walmart. So Open EdEx. I don't know if you guys are familiar with Open EdEx, right? So you'll find not companies, but uh, a platform like Open EdX, which Stanford has there. See, most of the university use this platform to offer up classes. So you'll find a lot of uh, colleges have partnered or offer use Open EdEx to offer up training. And so here's a list of those colleges here. They also have a Slack group, and they also offer uh, to build out their you can build out their stuff. So a good one that I use is cloud.google.com. I use Google Cloud often, and I'm just going to show you how quickly you can get like an. I think I already have it up, but I'll show you really quickly how to say you want to you want to play with OpenEdX, and say you want to make your own curriculum if you wanted to. Yeah, see, I already have one, but basically, let's say I want to create an instance. That's not how it is. Here it is. Let's go Cloud Launcher. And so in here, I can type OpenEdX. I think, let's see. Let's go here. There it is. And we'll talk more about Bitnami. And you can see I've deployed before. But they talk about the pricing and so forth and so on, how much it'll cost you a month, so forth and so on. And you just deploy this Open edX, and you get a login. Let me see if I can remember my login from my box. Let's see. Oh, it's down. I hadn't started it, so let's start it. Hopefully I remember my login. If not, you'll just hit the web browser. That's good enough to show you. All right. It'll pop here and it'll let me know what my IP address is. So there it is. Pops open. It's doing this thing. It just came up, so you got to give it a minute. So while that goes, we'll continue to talk about open source stuff. So there's Red. There's it's not Red Hat. I think it falls under Red Hat, but there's paid internships, open source projects, basically. And I forget what their name is. Outreachy. So you can join their organization as I think it's, yeah, they say exactly who they cater to. So there's another way to get into getting. This one is a paid one, so you get paid to actually do it. Okay, here you go. Whenever it decides to render. So there's Outreachy. There's Netflix with Chaos Monkey. There's OneOps with um, OneOps with Walmart Labs. Chase, open source, and yeah, here we go. Their commitment. Here's JP Morgan Chase, and here's their commitment to open source. So when I talk about Linux, I'm talking about Linux as like just a foundation. So, let's talk about, a little bit about what I mean about foundation. So I'm on my Mac right now. And so let's go over here. Let's see, I'm trying to find a box that's actually open. Let's go here. Let's try that one. I think that was 427. Okay, yeah. All right, so I'm on my Linux box, which is out at DigitalOcean. And I'm on CentOS 7.3. So, did I reach it? There it is right there. So as you see, I've been playing around with it, just setting up courses and learn how to do a one-on-one. I think it's probably still in French. It's gotta render. It's so slow. My network's been slow. But let's go over to, oh, it rendered. There it is. Here you enroll, estimated time. As you can see, haven't been playing with it in a minute, but you know, courses and so forth and so on. So that's just a small glimpse, and I launched a Open EdEx instance on Google Cloud to give me this web interface, and then I can upload my YouTube clips from here, edit them, and pretty much set up a course. So just that simple. We talked about outreach. All right, so let's talk about CentOS and Red Hat. So it's CentOS versus Red Hat. Now let's go something in more recent in the past year. So here we go. There's some, you can take a gather of that. No, I'm not using. I don't think they're using Apache for those web pages. I think they're using Nginx. So why do I choose CentOS over Red Hat for our classes? Well, one is just cost. So what do I get in that cost? If I paid for Red Hat subscription, I get support. There's no paid support for CentOS. It's kind of like, either you know it or you don't, or you know how to find it or you don't. That's really what that boils down to. So knowing how to find documentation and knowing how to find your answer, because CentOS is upstream to Red Hat. So basically, when I say upstream, it's kind of like a good idea would be like the car show. When you go look at the car show and you see like the car shows in Detroit, and they say, "Hey, the latest and greatest model. We got a model coming out of, say, the Tesla or what have you." That means these are the new features. This is what the new body style could possibly look like. So then you come out and you say, "Hey, I'm going to, I see the model, but, you know, when that model comes out, maybe a year from now or 2 years from now." So when it does finally come out and it has all the new latest and greatest features, we consider that in tech upstream, versus CentOS is upstream, versus the model you have now is kind of steady. They may release some updates, but it don't have all the features of the new, like the new car may have. So that's kind of what happens with, in tech, and it happens in cars. So for this, CentOS is considered upstream. So when we look at it, it's cutting edge, but it's not. Fedora is more cutting edge than what CentOS is. So Fedora, and when I say cutting edge, it means their release dates are a little bit more frequent. So Fedora, I think their releases maybe every 3 months or something like that. Let's look and see what Fedora release dates. Fedora release dates. Yeah, there you go. So yeah, see, 2050. Yeah, it looks like their schedule. They're coming out every 3 months. Versus, so with that being said, say I build out my infrastructure and I'm using Fedora, say for my laptop, and I just and just in Linux and in general, when you get a new laptop, it take you a while to get accustomed to everything, and then all of a sudden, boom, a new release is out in 3 months, and you're like, wait, I just got updated. I just caught up to what we needed to do. So in production, most people don't use Fedora. Most people use CentOS. So CentOS release schedule. Let's see. Stable, still supported. I want to say their schedule is every 6 months. Let's look and see. Let's look. So that got released on November the 3rd. I think it's still in beta for for us in what you call it in Red Hat. Let's see if they got a release date. Let's see if we can follow the releases. So that's CentOS 6.8 and CentOS 7. Let's see. Maintenance update, full updates Q2 2017. Let's see if they got an actual date. And actually, CentOS, what they did was their latest ones are. So let me go back. Let me show you. So here, see, it's 7/3/16/11. That was the day, the month it was released, 11/16. And I think for 7/2 was 11/15. So it's not as often. So it may be a year apart for them for their releases. Yeah, it may be a year apart for their releases. So you may not, it may be 6 months or a year, something like that. But that lets you know that, you can kind of stay along with the version, like at least, for a while. Let me see. Yeah, they don't have it on here. So that's really the major difference. Like the release schedule, and the cost. So because CentOS is similar to Red Hat, I always tell everyone go get you a Red Hat account because you can use their documentation in order to solve the problem that you may actually need. So if you scroll down, let me see if they have it down here at the bottom. Customer portal, and if you can continue down, you'll see product documentation. And then the documentation is kind of vast here. In our case, we're looking at Red Hat Linux. So it's under Red Hat Linux. And then they have a knowledge base that you can search. But then here's the release notes for each one. And release notes are always good to read. It's kind of like telling you what they're working on, what's wrong with the product, and what they upgraded in the product. So like you may look at 7.2 and they might have said, hey, we're just doing what they call a tech feature. In other words, we're trying this tech out, these features out in this particular release, and then in the next major release in 7.3 it'll be officially in the core of the actual project. So you may want to look at something because you may want to implement it. And I do it all the time. You may want to implement something, but it's a tech release inside of 7.2, meaning they don't really support it if you have a problem with it. And then when it comes out in 7.3, they may actually support it. So let's look at, desktop here. And then here they they talk about the version that they're going to, some of the features that it has, or some features that they're taking out, some extensions they upgraded to. When you look at security, they talk about, what's been disabled. They added a policy. OpenSCAP still stayed the same. Here's the security guide. So, it's things that, you say, hey, I wonder if I can do it in 7.2 or in 7.3. You can come here and look and see like what's actually, if this will be a good candidate for you. Like, should you be using 7.1 versus 7.2, or so forth or so on. So that's the major difference there, in terms of like understanding the release notes. And I was always sign up for a Red Hat account just so you can get the knowledge base and so you can go out and check out the documentation. So let's scroll down here. So you get a installation guide. You can come here. It'll show you like how the pages are laid out in a single page or a PDF. You're migrating your desktop. So just don't get this confused. There's no direct migration from 6 to 7. You'll read this and they're just going to give you the differences because there's no direct migration from 6 to 7. It's a clean reinstall. So in terms of a reinstall and why you're reinstalling, it's because Red Hat 6 uses ETXF for its file system. And let's go here. EXTF, sorry, EXTF, mean 4. I don't know why I say ETF, EXTF for its file system. And then for CentOS or Red Hat 7 and up, they use XFS. So let's go here. And this is always something good to know. And this is what some people will ask you on a interview. And this is fine. Let's go here. Open benchmark is always a good. Let me see. They break it down. So here you can go and look at this later, but they talk about the file systems and the performance of the file systems. Okay. So this website is a good website to know, like when you start looking at things. Let's go back one. And let's look here. See, I always look for check marks when I'm scrolling through here, so don't pay me no mind. I'm looking for check marks, meaning it's been approved. And Wikipedia is okay, depending on if it's got enough information here. Let's go here. That's Veritas. No. 94. All right, so here's XFS where they talk about it right here. And let's scroll up. What is this second column? What are the columns? Maximum path length and allowable character directory, maximum file length, maximum file size, and maximum volume size. So you can come here and look and do a comparison between XFS and EXT4. And they'll talk about it down here. Let's go next. So you can do a comparison of, let's highlight this. Actually, let's go back. Let's grab, come on, let's grab just this guy. Let's go this way. All right. Oh, come back. And let's put them in text edit. And go here. All right, I'm gonna move this off screen. And we're gonna go back. And we're gonna look at XFS. And don't just rely on this documentation. You can go back to the documentation of Red Hat and do the same thing, and they'll give you a little bit more detail than what this giving you right here. We're just highlighting some stuff, as you can see. So let's go here. All right, I'll bring this back. It's just a cut and paste. Hold on, don't change up on me. Look at that. Really? All right. All right, so here, what they're saying, let's go move this off one more time. And then we'll scroll up so you can remember, don't have to memorize. All right, so basically what they're saying is, here's the maximum file length you can have, allowable characters in a directory, any byte except null, maximum file length not defined, but here's where the difference is: the maximum size of a file and you should never have a file that's 16 terabytes, and then we're getting into exabytes. So XFS is able to handle more. And so when we start talking about things like big data and file systems and so forth, that's where you're starting getting into stuff. And really XFS is really small in comparison to other file systems. So let's big data file systems, which is HDFS. And I don't know if they're gonna break down um if they're gonna break down like what it's able to handle. Yeah, see, they don't break it down. But anyway, so something like HDFS can do more than what XFS can do. So that's just a FYI there. All right, and so that's your major difference between 6 and 7. Does that make sense for everyone? All right. So back to what we were doing. We're on 7.3, which was released in November the 16th. What else is unique about this box is I'm going to sudo the root. I can do a uname -- help, right? Why am I doing it? I'm going to show you the kernel, the meat and potatoes of the OS here. So here it tells you I can print the kernel name, I can print the kernel version, I can print hardware about it. So let's clear this and let's run that again. And then I'm going to open up another window. Control that. Let's clear that. Let's go. What is this guy? Him. There we go. All right. All right. So here, I'm going to type in uname -a. And it tells me, one, my host name. And remember, the -a does everything. My kernel, it gives me the date. I believe it's the date, the build date here. And then if it's 64-bit or not. That's what I'm getting there. Now, if I just want the kernel name, you see, I'm just doing Linux, right? That's what they named it. But I want the version. Let's see, and then machine 64-bit, and then platform still 64-bit, and that's what you saw here. Platform 64-bit, machine. Let's see, I bet you OS would be 64. Linux. So, let's go processor 64. Okay, and then node name, and then it gives me my node name. So this is all information you will possibly need in order to know your kernel versions and so forth. So let's talk about that. It's this little fancy little website called kernel.org. What is special about kernel.org? Well, let's look at this. My latest kernel for CentOS, remember what I talked about being stable, is 3.10. Now let's do a yum update and let's see if we get a new kernel. We'll let that run in the background. But as you can see, the latest and greatest stable kernel is 4.910. So what that says is when Red Hat or CentOS make their release, they're making a release based on older kernels. And look, they're well past. They got for 2017 in February 2017, they have 3.10, 3.12, 3.16, all the way up here to 4.10 is a release candidate. Their RC is a release candidate, so it's not stable. So 4.910 is the latest and greatest. That's the stable one. So what does the kernel have? The kernel has everything. The kernel has all your drivers. CD over to I think it used to be user source Linux, so it's now user SRC kernels. So let's clear and let's go into this directory. All right, so everything about your box, everything about your instance, everything about your hardware is all resting on this kernel. And your kernel has information about everything connected to it. So let me show you lspci. So okay, it's not installed. I have to wait till it gets done. Let's see if I can do it lsusb. Okay, not found. So I have to wait till these things get installed. But basically, if I go to net, any anything in terms of like when I do IP ADDR, which gives me my networking information and so forth, it's located in here, like how it should be treated. Like, is it a some good ideas? So you know what I'm talking about. Nick card examples. So say I got a NIC card from that's an Intel versus a Mellanox, right? Inside of this guy here, inside this directory, it holds the drivers. Just like you do in Windows, you have to install a driver for a particular device you want. That's what the kernel does. In fact, Windows has a kernel as well too. So that's what you find here is, hey, I have a particular device. This device has a particular driver that I need, so I need to install that driver into my kernel in order for my software to communicate to that device. That's what your driver does. And some drivers, I mean, at the core of it, that's what it does. But then you get a little fancier with features, in the driver set. So your a good idea would be your USB headphones. Um, your USB headphones, they have drivers as well too. Like, say I plug in a driver and it needs to do some type of communication, and in terms of sound and so forth. That's what that comes from. So now you have sound for your through your headphones plugged into your laptop or your particular desktop. It's a driver that pushes that. Same thing here. That's what your kernel is. Without it, do you think anything would work? You can answer yes or no. I'll wait. No answers. No one wants to take a stab at it. Do you think it would work? You think it will work without the kernel? The answer is no. It won't work without the kernel. Like, the kernel is your meat and potatoes of your your meat and potatoes of your operating system in Linux and in Windows and in Mac as well too. All right. So that's the thing behind the kernel. And then here you see here's the latest and greatest. I can download this, and then I can what we call uh, I guess, massage, you could say. We can fine tune the kernel to be what we need. So by default, Red Hat, when they make their release of their kernel, of their operating system, they put everything in their kernel. So you may not need everything. Like if you have a machine that's in production, you don't need Bluetooth for a machine that's in production, that's sitting out on the web, because it doesn't need to have Bluetooth. You don't need to have sound running on your machine that's in production, that's just taking in log info, log information, because it's just a log server. Like the rule of thumb is least privilege. So in other words, when I say least privilege, and this goes across security and in your boxes, it means give me the least, make sure it has the least amount of privileges in order to function. So it's kind of like somebody comes over to your house. You don't let someone go upstairs into your bedroom unless you really know them, right? So when, like, especially if you're having a party at your house, it's the same concept. They come over to your house, these are the areas you're free to roam, anything else is off limits. And if somebody steps outside of those limits, then you have to question them, right? It sends off a flag. Same thing in security, same thing here with what we're talking about. When you're talking about your kernel, you want to kind of de-bloat it down to to what you just need. So that requires you to come out here and do like kernel builds. So, and we may get into this year, building kernels from source. Let's go in the past year. Okay, you come up. Let's try you. Let's see if they talk about it. Yeah. Yeah. So you see here, look, you see, they go to kernel.org and grab the latest and greatest. They walk you through on building the kernel, the configuration of it, how everything should be set up, make menu config, the whole nine. It's a process, and I used to do this when I started out. I started out rebuilding kernels. Like, hey, take this and understand what each piece does. Literally I would go through and tell you exactly what each directory means. Like if you go up one, the firmware, the drivers, block devices, libraries. I forget what is. Net, you know what it is. Network, security, sound. Virt is virtualization. User, that's usually like user lib that goes on the libraries. Scripts. Let's go over to scripts. Let's see what they're talking about with scripts. That was new to me. Let's see. Check your version. Check clean. Okay, this is to build. These are your build scripts that you need to build your kernel. So basically, we could actually build out a new kernel and strip it down to its nearest smallest level. And so we only need the basics for it. Does anyone have any questions? Anyone lost? No? All right. So that's the basis there of Linux, is your kernel and so forth. So, all right, let's go and show you Fedora. You've seen the differences between Fedora. You understood open source projects. Uh, Migration, we talked about going from 6 to 7. Uh, Performance tuning, that's another good one that most people don't really cover. There are more advanced classes. So performance tuning, when we talk about performance tuning, it's just like increasing the performance on your car, or increasing your own performance in your own life, right? You find, like, if you eat like a steak every week, like a steak every day, you probably won't have the best performance body wise, right? Across the board. uh, versus you eating a salad every day and or speeding up your metabolism eating 6 times a day. That's what we're talking about here when we're talking about performance. You can break performance down into, and they have a guide. And as you can see, here's the class. Uh, we could talk about performance by even like the memory. Like if you have a machine that has a lot of memory, you can set it up where, or we won't go to the class. You can set it up where you're like, okay, well, I want this machine when it's running this actual particular script, I want it to use these two processors and this bank of memory. You can break it down to that. So that's what you get here when we're talking about performance and performance tuning. Here, here's like they're talking about IO stat, input, output, uh, system tab, your plugins, tuning. Here's your CPUs, looking to see how things are running. Certain machines have GPUs. You guys are familiar with GPUs. I leave this for you for homework. Look up GPUs. You'll find it quite fascinating. I'm gonna go here. Here we go. Let's see. That's an older one. Here. I mean, you can use Ansible to perform some performance tuning, but it will be slow. You want to do something in real time, and that I posted that link today. Chef versus Puppet versus Ansible. They talked about the performance hit that you get with Ansible, the performance hit that you get with Chef, and the performance hit that you get with Puppet. I advise you guys to go back and look at it. If you're not a part of our Slack group, you should be. If you want to be, it's Women in Linux at slack.com. I think we have to send you an invite out, but we can send the invite out. I think Shanika and Sergio know full well how much information is in there.
And the graphics processor is...
Okay, so here we go. That's another one to check out, just so you can familiarize yourself with when people talk about GPU programming and CPU programming and so forth or so on. So that's just a good FYI on that. All right, let's see what else I want to tackle for you guys here. Any questions just randomly you may have while I get back to this, before I get back to performance? Oh, yeah, it's a good one. When you're talking about solid state drives and scheduling, this is a good one. Um, yeah, your e-tool. Let me see. Is it done? Okay. So it it updated. Let me go to the to log. So when it updates, right? When you do it, I did a yum update. If I go to var log and I do a ls minus ltrh, all right, you'll see it's 1949. It stopped at 1937, so about 10 minutes ago. But you'll see here yum.log. This is where it lets you know what it installs. So let's do a vim and look at yum.log. And vim is just a way for me to look at it. All right. So it tells me what got updated. As you can see, it tells me what it was, some things that were new that were installed. But I want to know, what kernel was installed, right? So there's a couple of ways I can do this. I can cat yum.log, and I can just grep, and I'm gonna ignore the actual case and do kernel. So it tells me that it updated the tools that I have. Let's go and uname -a. I'm in 3.1. I'm 3.10.0514. So it updated some of the tools, the libs, and the header, but it also and also installed the kernel 3.1.6. As you can see, I have 2.2, and then it installed to 6.1. So my kernel got updated. And right now, my current kernel that I'm running is the older kernel. In order for me to get the new kernel, I have to reboot my machine. Another way I can see if it's installed, I can do an RPM query. I can do RPM QA, and I can grep for kernel. And I'm gonna do, I should do a -i, which it doesn't matter, it's all lowercase, but just for your own edification there. And you can see these are the current RPMs that are installed on my system. When I'm doing a yum, and doing a search, I'm actually going out searching all the repositories to see if it's available to be installed. But you can, I think you can do. Let's do a man on yum. I think it's called is install. Let's go installed. Reinstall, install. See, install. It may be the RPM. Let's look it up. Let's see. Yum is installed. Yum groups. And I'll just give you this link too. This is important when you're working with RPMs and Yum and so forth. Let's see. Can I not get it? There we go. Let's look here. I was looking to see they have is installed. And it may be under RPM. Let's see. And it just came out within the past couple of years. I don't see it, but there's a way you can run the command is installed. All right. So now you see what my current kernel is. And also, if we go here and vim etc default grub, they don't have it in there. Let's go boot. Grub 2 grub config. Alright, this one, just bear with me, it's gonna be a little hairy for you if you're just seeing this for the first time. Then we go kernel. Alright, so as you can see, I have a rescue mode kernel here, right? And then the next menu entry, I have my 3.154.61. And then I should have the 3.22 here, as you can see here. So when I reboot, my default kernel, it goes, it's going to come here as my default. That's going to be my default. Let's see. Let's go set default or get default. kernel rel 7 or CentOS 7. Let's see, configuring bootloader, making temporary changes, customizing. Let's see. And this is the file that we went to, grub cfg. Under that, you saw that. Let's go. Let's see what we have to do to make it. Man, this editing and going in and changing stuff, we don't want to do that. All right, here it is. To find out what the kernel, our thing is, and if I don't know if you noticed, right? I'm gonna show you something. I don't know if you paid attention. When I did a ls minus ltrh, you see that grubby? You see that was changed, right? I'm gonna go over some quick file permissions real quick right here. All right, let's go over this really quick. So for you that are new, I'm gonna explain these file permissions really quickly, but there is a YouTube out here where I actually went over these file permissions. So this D stands for the directory. The R, W, and X are read, write, and execute. So just like what it states, I can read, I can write, and I can execute. But it's broken up into a group of users and groups and others. So I'm going to put this over here so you can better see what I'm talking about. Oh, come on. Oh, yeah. It don't matter. We don't need all that. All right, so this guy. That's whatever. I'll change the background later. All right. So I want to put this down. I'm going to create a new file. drwx. And let's make this a little bigger. And maybe 36. Okay. So D equals directory. If it has nothing in front, it's usually a file. Like you don't see anything here, that tells me that's a file. L is a link, a soft link, and you'll usually find that in, if I do ls and user lib, and I'll do ll actually. Let's do ll minus l. Sorry. You see that right here? You see that L there? And then you see it's pointing to something else. That's a soft link. Alright? So that's usually what you'll find in the beginning. Right? The next one, when we break this down, we got R is equal to read, W is equal to write, X is equal to execute. Right? And the way this works is, oopsie, it's going to get funky. I'm going to put 4, 2, 1. So basically, all the bits are on for this particular user. And the way this works is, we'll just do 1, 2, 3, and then I'll put, to divide that up, 1, 2, 3. I'll divide that up, 1, 2, 3. Okay. And usually how this works, it goes user, group, and other. And I should spell that out. And you know this is group. Okay. So when you're looking at these permissions here, I'm just going to grab these permissions. And put it down. I hate when it did that. And I'll make this a little bigger. Alright. So here we know from up here it's a soft link. Here we know there's the group, and every 3 is the other. So, come on. There we go. Alright, so this user gets everything: read, write, and execute. The group gets read, write, and execute. And then the other gets read, write, and execute. And from this particular one that we were using as an example, this column here, this tells me who's the user and the group. So in this case, the root person is the user, which gets read, write, and execute, and the group gets read, write, and execute. And in order for anybody else to use this particular file or what have you, if this was gone away, if this was this here, they would have to be a part of this group in order to access that file. All right. So let's go over some of these things. We can delete that one. All right. So what I was showing you was good old Grubby. All right. In this case, it's owned by root as a user and as part of the group as the user group. And then the only thing that everybody else can do is nothing. And it tells you right here that nobody else can do anything to it except the root user can read and they can write. And I know one thing, it's a file. So let's clear my screen and let's cat Grubby. Now Grubby is telling me some things. I can read and write. And what did it do? It read and it wrote to a particular file. And it added some content. That's what it's telling me. It's telling me that it made some changes. I added the kernel. It's telling me everything that I needed to know. Why did I bring that up? Because here is your listing of your default kernel. Grubby -- default kernel. All right, so let's run this same command, right, and see what's going on. I can do this. I can say which Grubby. I'm gonna go over to my temp directory. I'm gonna say which Grubby. It's gonna tell me SBin Grubby. All right, so it's in my path. It's in SBin. I'm gonna cut and paste, and it's telling me my default kernel now is 5.14.6.1, but my current kernel that I'm running is 5.14.2.2. Everybody see that? So in order for me to get that kernel that's currently installed as my default, I gotta reboot. That's the only way I'm gonna get that current kernel. That's the only way I'm gonna get the latest and greatest kernel. I'll continue with the current kernel, but if I want my latest and greatest, I gotta reboot. So let's reboot. And it should only take a split like less than a minute. They come up pretty quick. Any questions? Does all of this make sense for everyone? Has this been helpful for everyone? All right. So I'm back in business, right? Well, what kernel am I gonna have? I'm gonna let you answer that. What kernel am I gonna have? Can you see it? Can you see my screen? What is the latest and greatest stuff? You can say it.
Um, it's the grubby one, right? The
No,
3.1.
no. So Grubby is a file, right? Grubby is a command and a log file to let me know that I installed my latest and greatest kernel. My kernel is
Is it
is this
10
is this right here. It's the 3.10.0514.610. All I did was with Grubby is I said, which Grubby am I using? Like it's an actual command. And the
Mm-hmm.
last thing I ran was, let me go over here to root. I did Grubby and which is in my thing. Yeah, we go. I said, Grubby, give me the default kernel you have right now. Grubby said, hey, I know how to do that.
Mm-hmm.
I'm gonna go read this file, which it read that cat uh um boot grub grub, come on, not you, it's grub 2, grub.cfg file. It read this file and it said, I know what the default is. And not only did it read that file, when we go over here to var log
Mm-hmm.
and we see good old Grubby right here, it's greedy, Grubby. Grubby said, "These are the changes that I made. I installed a new kernel. I put the title in. You can see I moved the image entry succeeded. All right. In other words, it took over what used to be my latest and greatest kernel, and it gives you everything. It gives you the timestamp and everything." And that's it. So let's look at what does DBG mean for Grubby. Let's see. Do they tell what that means? Let's see.
What?
It ain't designated black guy. It's not designated black guy. Grubbing definition. Hold on. What happened to my grubby? Here we go. Well, at least we know that exists, huh?
I know.
Let's go
What
Linux.
else is here? Let me see.
Let's see. Do they tell me what this means? Well,
Style,
well,
filter,
when all this
margin.
fails, this is what we
Mm-hmm.
do. We do man on grubby.
And on Kirby. Oh, and then it gives it the descriptions right there.
Mm-hmm.
Mm-mm.
Special arguments. As you can see, it added the kernel, remove the kernel, update the kernel, arguments. Let's see if they got was it DBG?
Yeah.
Yeah, it's not in here. So
Mm.
I'm going to make some assumptions here. DBG default G DBG. I don't know. The grub 2, I guess default grub something. I'll look it up and find out what the DBG means. But that's what happened. We're on our new kernel. We've updated our machine. We looked at what it means to where we can find our stuff in yum.log. Um, See what updated, what it
Default
installed.
Grubby directory. I don't know.
So we got a lot of information out of it. Any questions? We know it's not designated black guy.
Mm.
I
No.
have a quick question because I stepped away for a second. You updated the kernel just with Yum update?
Yeah, I could have did just a yum update kernel,
Oh, kernel. Okay.
but I just did a yum update overall, and it's telling me like basically it's not in there. So
Okay, thank you.
let's go do devel. Yeah, I can do a yum search kernel, and this is everything with the word kernel in it. And as you can see, I have a debug kernel I can install, which is great when you're looking at trying to do debugging on your scripts and so forth. The crash kernel can be installed when you're doing running scripts and you're on the high end and you're running out of memory and stuff and you need to reserve a crash so you can do here with tell you can do a crash for live systems, net dump, disk dump, all of that stuff is important. We can also do it for um, um, where is it at? Do they have it in here? No, let's see. All right, Valgrind. All right. So you'll see this here for memory management and bugs and so forth. So Valgrind, rel, or let's go CentOS 7. Let's see if they have a document. Uh, let's go back. Let's go background. How to use. Install it. Syntax question. Installing Valgrind. Valgrind. Alright. Alright. Using Valgrind. Alright. So let's go back. So Valgrind, as I say, is a tool to profile application. It can be used to detect various memory errors and memory management. You'll usually find this in that Red Hat performance tuning. This is part of that. And then we have 3.81. So then here they break everything down, like how to monitor the heap, detects multi-threading, cache misses, memory management, all of that stuff. So as you as you get into distributed systems and so forth and so on, you'll start seeing this. Let's see if anybody see, using Valgrind in production. Let's go for the past year. See, somebody at Stack Overflow is using it. Understanding memory leaks using Valgrind. Here's an article for you doing a mem check. And they talk about what a memory leak is. So there's be something great for you guys to understand and know just on GPs. In case somebody ever asks you on an interview what's a memory leak, you can you can use Valgrind to figure out where your memory leak is coming from. So uh, here's a more updated version of it. Let's see if they see. Here's some books. Oh, let's go to a quick start. I'll go back. Yeah, so my program background check, blah blah blah. Interpreting the memory check, what it all that means, and they break all that stuff down. If you're a coder and you have a program, it'll be good for you to use this so you understand. Because systems have been taken over from memory leaks. System takeover from memory leaks. Yes. Yep. It is a good one. I think it's a video. Yeah. Figured this guy was a video. He's been around for a minute. And he talks about it. It's a good one. It's good handy knowledge. Alright. So we talked about memory leaks, we talked about kernels, we talked about updating kernels, where to get the latest and greatest kernel from. We also talked about uh, we didn't talk about processors, but we did talk about performance, CPUs versus GPUs. Uh, I've also shown you some basic information about Linux, but let me show you a little bit more. Let's go over here to slash. So slash is your root file system. All right, it's your beginning of everything, and everything kind of falls under that as a tree. I may have it in here, ls tree. No, is it ls tree? Oh, it's not ls tree. It's just tree. Okay, I need to install it. All right, you see all of this, right? I'm gonna show you this. Let it do its thing. All 20,750 directories. So let's do a tree. Let's do a list. All right. Remember, it's starting at slash. Right? It's starting here at my root at the tippity tip top. And I'm gonna say tree. It's making me I guess a pathway or a directory structure of how everything falls under root. Right? So you see bin and boot right here. All right, let's quit this. Let's do it ls. You see bin and boot right there. You notice that when I did my tree, it's a link, a soft link. That green or that blue green signifies that that's a soft link or a link, and it points to user bin. So let's clear that. And under this tree, it's telling me under boot, I have config, and then it tells me I have this directory, and under that directory is this guy. And then grub2 under that directory is these guys. And so we can see that from here. Let's go look at boot. Let's do it ls. So you can see by looking at this, grub2, under grub2, I should see device maps, and then fonts, which is a directory because there's something under it. You can't have anything under a file. You can have stuff in a file. So that's how I know it's a directory, because my next tail, or my next leg, is unicode.pdf. So let's go to grub2. And under grub2, I should be able to go to fonts and then unicode.pf2. So I should go to grub2, which we see here is a directory. And if we're not sure, we can do an ll, and we can see that there's a directory, right? So let's clear that. Then I can go to grub2. I don't have permission, but let's go here and sudo that. All right. Am I there? No. I need to be root. Now back to here. On the grub2, I see fonts. And fonts is a directory. I knew that from looking at this. And then there's Unicode. And that's the only thing that's in there. There's the Unicode. And then I can also do this. If I don't know what it is, I can do unicode.pf2. And it's just tell me some type of data. I can go up one more. And I can do file grub env. And it's an ASCII file with very long lines. So let's do file on device map. Another ASCII file. So I just did a tree on my entire system. I didn't have to. I can just do tree on say opt. And in my opt, I have some config files, and then I have a directory. And then under that, I have some files. And then it gives me a total. One directory and 27 files. Everyone see that? That's tree. So, reason why I was showing you that is because we can break each one of these directories down. The boot directory usually has the kernel that you're gonna boot from, or you're gonna boot into for the entire device. And then we have hold one second. Then we have home, and home is really where your home directory is at. Let's see, let me go here. That's my home directory. Hey, who's that? Someone's loud. And then we have opt. Usually opt is like where I want to put miscellaneous files, stuff I want to download from the internet. etc is your configuration directory. It's all your config files. And dev is usually like your devices. You'll see character devices. If I do an LL on dev, you'll see, look, the C's stand for characters. If it's a B, it's a block device. And remember the L and the D link for L, D for directory. So these are character devices. And you can make character devices. All right. Lib is usually, so we used to be between 32 and 64-bit. So lib is your 32-bit libraries, 64-bit self-explanatory, 64-bit libraries. Lost and found is what you find when you create partitions, and sometimes they get corrupt, and so it goes and throws stuff in lost and found, and you can recover. You can do file check, a system file check, and recover from it. Media is what they came out with. It's a directory that they came out with in recent times. Just like it sounds. If I put a CD into a disk drive or CD-ROM drive, and then mount it, if I needed to mount, it mounts under media. It auto mounts. MNT used to be where some things were mounted, but MNT now is kind of reserved for remote file systems, say using NFS or so forth and so on. You'll find it under there. I told you what opt is. Proc is special. Proc is real time file system. Like, so if I can cat proc, it's let's say yes. Let's cat proc anything I want to know that's going on in real time. This is my CPU info. This is what my CPU info is. Let me see, disk stats. This is what my disks are doing right now at this moment. If I want real time stuff, you go to proc. That's for real time. Root, of course, that's your /root is the user root and its home directory. Run is new. I'll look that up in a minute. SBIN, so user and SBIN. SBIN is usually reserved for root. So SBIN stuff are things that only root can run unless there's special file permissions. And then user is usually what the user itself can run. And when I say there's a difference. I can make a user add who knew? And then that particular user, let's see, let's do an ls on sbin. Let's do an ls minus l. Uh, all right, so let's do an ll. Let's see. So I look at these. I have rewrite execute that's owned by the user. That's user and group. So here the rx I can execute. I can read and execute. So certain things I can do, but like a Unix update, I can't do that. Let's look at other stuff that I can do. So for the most part, it looks like you can run some stuff. Let's see if it actually works. We'll try it out. Let's look at do 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 do. Let's see. Let's run ifstat. See, it lets me run it. I know I can run it because it put it under. I had the execute permissions. So let's exit out. It's clear. Let's go here. Let's go over to that's user sbin. They stuck everything on the user sbin. All right, that's fine. And that's just a link. SBN is just a link. it used to be stuff under stuff under user bin was for everyone. And anything under user S bin, you couldn't run it. That's how it used to work. So they changed that up some. And then your SRV, I'll give you that in a minute. Sys, I think if I remember that, I think this those are links like to system. See, yeah, to their devices. So usually a kernel, and then there's some parameters there. And then temp is your temporary directory. Usually gets wiped every time it reboots. User, we just discussed that. In var is where we were at earlier. We were looking at log files under var var log. And then when you install HTTPD, it puts everything under the www.html directory for your web browser, for your not web browser, but for your like Apache configuration. And that's the gist of the file system. The only ones that we didn't discuss are the SRV and run. So let's go here. CentOS directory. Alright, this contains specific data information about your system. This directory gives users the location of data files for particular services. Okay. FTP, CVS, so let's go there. I don't see anything, so I must not have run running. And then, what was the other one? SRV run. Was it run? Alright, let's see. They don't talk about it. Just give you a hierarchy. Let's see. Run, proc, var user run. Inside the run contains the runtime data for processes started since the last boot. Alright. Alright, so things that started since the last boot. Okay. Here's a PID for SSH. It's RPC bind. CD RPC bind. Nothing there. So this just updated information. I'll give you this link as well. And I'm going to start recording. Oh, did I not record the whole time?